mentioned if you type 3 dot character behind a command, that means there will be a dialog pop out to interact with the user. So we have save, we have open, and as you can see, we will have so-called menu items here. So this menu open to a straight menu item. Okay, so let us click on it. And after the file is saved, we intended to save the model as a text file. And later we will show you an example of the file. So we needed to set up a format so later on we can read it back in order to reconstruct the original model. But before we carry on, let me modify a little bit about our variable. So initially our main phone has 3 models ready there, right? But last time we kind of instantiated the model right on this button click. This is not good. You see, when user click this button, we kind of reinstantiate the Mandarin fuzzy set. But in this case, user may not have a chance to set the properties of a fuzzy set, right? For Mandarin fuzzy system, we let the user specify the type of defuzzification, and also the fuzzy set model. I mean, when the main phone is created, which means that we are not going to reinitialize any fuzzy system model. Okay, and we have recurring properties. We already have a constructor defined there. Yeah. For Mandarin fuzzy system, we ask for a rule set, right, in order to create a Mandarin fuzzy system. So in this case, we are not going to specify this constructor. So the constructor is a default constructor without taking any argument. But what about the rule setting? So it will be okay. So in this case, we will prepare a function, public function. We call it update rule set. So in this function, we ask for the sets of arrays of Mandarin if-then rules. And then it's very simple. All rules equal all rules. Because right now our data member and the local variable has the same name. So in order to distinguish the member data from the local variable, we need to add this here. Okay, this is the way we reorganize our Mandarin fuzzy system. So then let us go back to the button click. All right, so here we were not going to reinitialize the Mandarin fuzzy system. We simply invoke this function. So Mandarin system dot update rule set. And since it asking for the array, right? So, but this is the list, so it's simple to array will convert a list of object into an array of that object. Okay, so kind of. So this is the modification of our Mandarin fuzzy system. So basically we simply provide the default constructor, and then we provide another function to let user repeatedly update the rule set for updated inferencing. So that is the mechanism we modify a little bit on these three for this system. Okay, so it's about the time we prepare a safe model save function, right, and the open function. So we intended to save our model as a text file. Let us take a look at an example I have been using before: colon, maintaining number of input universe, colon 2, title x. So which means that this parts are the data related to this universe, right? So title, minima, maxima, resolution, such kind of data associated with this first universe, right? And within this universe, we have number of 3 fuzzy set defined. And there is interesting data here. Fuzzy set type. We need to provide the type. So it's a sigmoidal fuzzy set, right? That. And we have original hash code. This code will be reused later on when we store the rules information, because in a rule, the rule might refer to this fuzzy set. So the only the data we need to refer is not the address at all. So, but instead we will store the hash code for this fuzzy set into this module. So later on we can retrieve that back. So let me find it. So as you can see, this is sigmoidal fuzzy set has been defined in the universe, the first universe X, right? But later on, you will see it repeatedly happen here. You see, we have what? This part should be the number of rule row, number of rule column. So it's kind of data related to data review, right? So we keep all this stuff here. So later on, if we read in that sigmoidal function, we instantiated that objects. By that time, the hash code will be changed. So later on, we needed to get the read in the save the hash code in order to bring the relations back, connection relation back. How to do that? So as you can see, the rule set. This should be the data review specified by the user to define the rule, right? So within this cell, actually we did not save the name of that fuzzy set at all. Instead, we save the hash code. So later on, we need to read the hash code back before we finish the model opening. So we needed that in order to make the reference complete later on when we import a model from our file. Okay, so this kind of format will be used in our model saving function. Okay. All right, so we kind of provide the model save function, right? So we can start from our main phone. Save model. So we were asking the file path. That should be a string. Okay, in order to save the data into a file, we need the help of a class called string writer. It is located in this namespace system.io. I call it SW created. So use the file path to create this string writer. So make sure you always close it. Otherwise, this file is open. No any other application can access it. So as you can see, everything has been stored within this form, right? So the model including this information, maintenance information, and the tribute store, the number of universe defined by the user, and the rule created store in this data grid view. Okay. So we will then start with the writing type of maintenance system. So we will check if RDB maintenance check it. So string writer, write a line, write a string, which is this formatted string. So I call it model. Right? Excuse me. Got a typo. So when you else if scanner else so how can we open model? We need the help from the string reader. So I'm going to call it SR equal new, oops, string reader file path. So before we end up this function, we need to close this string. Otherwise, it will be locked up by this application. Nobody can access it. Alright, so similarly, if you if you write the data output in this sequence, definitely you will read in the model following the same sequence, right? So in here we will prepare a local variable string. I'm gonna call it str. So this is the first line, right? So first line in our model file should be model colon maintenance or scanner or SCAR model, right? All right, so we will get it. So we ask SR read line. You don't need to supply any parameter. What you get is a string. So and then we get it string here. So probably the input file might be old a little bit. So probably the string is not clean, which means that probably they were preceding break later or trading break later. So usually we will when we read a line in, we will call trim function to trim out the appended break characters. All right. So after that, we need to extract the keyword, right? We kind of use this keyword to send to represent the type of the for the inference system. So we need to get this part of the keyword. So what you can do is that in the string class, there are a bunch of utility functions to help you get a substring. So basically what we need is that str will try to get substring. So this function, there are two ways to start index, right? Start from index. The second one should be starting in the length. So what we need to know is that the location after the colon, then to the end should be the substring. We'd like to pick it up. All right, so here we will ask the string find the index O, and then we put it. You see, there are 9 ways to call this function. So, well, definitely we will invoke the first one because we like to find the character. All right, so it will return the index or colon within this string. So in this case, that should be the 0, 1, 2, 3, 4, 5. Should be the 5. So we start from what? From that plus 1 to get the substring. And once we get substring, we kind of rewrite it to a string. Okay, this will be our keyword, right? So either way, it's a Mandarin scanner or it's Komodo. Oh, fine. So we will switch. We'll switch str case. So if you are familiar with C or C++, it is not allowed. I mean, for the case identifier, it should be restricted to int only. But in C# we allow integer or string can be specified as the case symbol. So if case is Mandarin, right? If it is Mandarin, then we will set what? RDB Mandarin check it equal true. Okay, so I think we have better prepare a local variable because later on we need to identify whether it's Mandarin or scan or model. So I better prepare a local variable. I call it model type. Model type. So assign it to the model type. Model type. So you will do the radio button setting by yourself. Okay, so you need to do that by yourself. I'm not going to cover all of them. All right, so first line is done, right? So it's about the time we store universe and fuzzy set data. Via the tree view. Right, so user keep adding the universe and fuzzy set on the tree view. Right, so we will store universe data and the fuzzy set data from the tree view. So, but before that, we should report how many fuzzy set has been declared by the user, right? So we always start from the fuzzy set and then from the universe and then fuzzy set. So I'm gonna call it int numbers. Right, and the number should be the TRV tree view fuzzy model, right? So we have a what? We have a nodes, right? So we have a nodes. Okay. Tree view nodes 0. So that is the categories of input universe. Then we find nodes. That should be the input universe, right? Input universe. So we get the count first. So then we loop through. Well, in here it's a input universe, right? So we kind of print out that information. Right line. So we might call it numbers of input universe number. So we reported that first. And then, so in the open model, right? So we have a number, right? So we use the string equal SR string reader, read the line again. I trim it, make sure everything is okay, and then I will get similar. I will get a substring. So that part will be this substring, right? So we know the substring can be parsed into int. So I invoke int.parser, parse this substring, and then convert it into number. So right now I know it's a number of input universe, right? It's a number of input universe. Number of input universe. Okay, so now we have. Okay, but before that, before we proceed with the readings, we have better what? TRV string node clear everything. TRV fuzzy model nodes 0. Okay, node 0. That node is clear. So then in set model file, I kind of look through. Well, in this place you can use for each, which is much more clear for you, right? Well, maybe not. Well, number of input universe. Okay, maybe not. For int I equals 0, I smaller than number, I plus plus. So we cannot look through each universe, each input universe. Okay, so I will catch up the input universe. Alright, so I define a local variable universe. UNI. So where did you get universe? UNI is what? From TRV tribute node dot nodes 0 dot nodes. The ISIS node, right? It's universe dot tag, and then we convert this tag from object into universe. Right. So we got a UI, right? So similarly, once we get a number, we clear up the nodes, right? So in this time, we will look through each universe here, right? Smaller than number, right? Plus plus. So here, since we just have one type for universe, so we don't need to specify the type of or particular universe into our file model. So universe, once we get it, we can directly invoke a function which will be defined in the universe to save the model. So we have file save model, right? So we ask UNI invoke is save model and then we pass the string writer to that function. So since a universe is an object, right? So from object-oriented technology perspective, we will let this object do the saving job by itself. We are not going to pick up data from these objects and save this data for them. They needed to provide a save model file. So I just passed the string writer to the universe. Universe needed to write their data in a similar format to our output file. So that is the idea. So we have a universe save model, right? But before we invoke another function, because right now we know there are numbers input universe, so for each one we will instantiate a universe. So locally I have a local variable. Similarly, universe UNI here, UNI, and UNI equal new universe. But we need to put a chart there, right? So where is your chart? CHA, I don't know, chart 1, chart control 1. I need to check that. In this version, the chart is right here. Is that right? Chart fuzzy model. Okay. So that is chart fuzzy model. So we instantiate universe this point, and then we ask universe to save. Well, let me change the file name a little bit. Okay, I might rename it as read save model, read model from this file. So I like to name the function for the universe as read model, and then I simply pass string reader to this function. So up to this point, I do not have these two functions ready, right? So it's okay, because right now we cannot design this an implemented function right here. So we will ask help from Visual Studio. So generate method universe.save model. Okay, great. So I added this save model file to the universe. So similarly, I can invoke this helping functionality of the Visual Studio, so I get it. So then we kind of enter this save model. Right, go down there, go to definition right here. All right, so Visual Studio add these two functions for us, save and where is read? Wow, I just have save. Where is the read? No. What's wrong here? Save. Remodel. Universe. Where is the universe? So let me move to this function again. All right. Okay, this is read. Where is the save? Save read here. Okay, I kind of move this function up a little bit. cut it and move to here. So by default, it is declared internal. So maybe because my class is public, so I had better change that accessibility into public. Save model, remodel. So right now we just concentrate on the data structure or a universe to see what kind of information should be saved into the file, right? Okay, save model. So the first thing should be the what? Should be the name. I think we have a name, right? Where is the name? Oh, okay. Oh, that's poor. Not the area name. It's not area name. It's a name. Okay, name is right here. So we need to save the name. And then we have minima, maxima, which has been declared as the. Okay, all of them has been declared as properties, so we need to save them. We don't need to worry about the tree node, the area stuff. Okay, so once the universe is created, especially the chart, so the area will be instantiated, right? The chart area. Yes, we already have area created, legend created, the node. Okay, fine. So what we need to set probably just those data. Save model right here. So we do the saving for the universe by itself. So we SW right line string again. Name. So once you want to read it, right? So you will do that. String str, right? Str equal string reader read line, trim, and then we extract substring str dot substring. Similarly, yeah, str index of find this character, and then the position shift to the right one character, so we get a substring, and we assign that as my name, right? So right name, rename in, and how about the resolution, right? And the minima and maxima, such kind of stuff. Okay, fine. So you should do this in a similar way in order to write all related data. Okay. So I'm not going to cover all the detail. So you need to do that by yourself, but following the similar procedure to print related data out. Save the related data out and read in following the same sequence. So let me okay, so we print now mean, right? So similarly print now, and they are quite a lower bound, and that should be what? That should be minimum. That should be minimum. Then I read in again. read a line, get the substring, and right now we know it should be int parser for this substring, and I will use that to set my minima. Yes. So you do the rest. For example, you need to put your maxima and resolution in. Okay, so that is the object-oriented model saving. Since the data is defined in your class, you need to prepare this function, do the save and the read operation by the class. Alright, so universe has been done, right? So let us go back to our main phone. So no problem. Each universe will save their data to the file, and then we look through the file set defined in UNI, right? It's fair, right? So where did you get the number, right? So I kind of TRV for this model. Well, probably yes. It's okay. Model nodes 0 dot nodes I. That is the universe, right? So I kind of can check a number of fuzzy set defined in this universe in this way, right? So again, I assign that as number. No way can I keep using the number. Number has been defined outside this in this for loop. So I'm gonna call it int fs number. So I have a block variable declared right here. And after that, so I kind of loop through int j start from 0, j smaller than fs number, j plus plus. We need to save the information about the fuzzy set defined in this universe. So before that, we need to write the number sw write line number universe, right? So it's about the time number of fuzzy set colon fs num. Okay, so since we have this line, right after the universe save, so similarly back to here, once universe finish the reading, it's about the time we read in the number. So int fs number. So we will read in this line. We will read next line int, and then change it, pass it into fs number. So after that, we kind of loop up j start from 0, j smaller than fs number, right? J plus plus. Okay, so make sure the sequence is exactly the same as that has been done in SAFE model. So right now we kind of dealing with the particular fuzzy set, right? So in here, in order to create the particular fuzzy set, when we read in the model file, we need to report the type. Report the type first. I mean for each fuzzy set. So in here, w write line. We try to report what? fuzzy set type name colon. So where is the fuzzy set? I may put a block variable here. Generic fuzzy set fs. Pick it up from where? From tribute TRV model nodes zeros nodes ice. That should be the universe, right? And under universe node is the child, the J's children. That should be a fuzzy set. And we store the fuzzy set in a tag. So tag is the object. We need to cast that as a generic fuzzy set. It does not matter that whether it is triangular or Bell or Gaussian fuzzy set. We simply treat that as a generic fuzzy set. But this time we needed to report its real type here. So fs is a fuzzy set, right? We should have we should get the type. So there is a class called type in Dynamic Framework. So how can you get a type of this fs? It's very simple. So I might have type of fs equal what? Fs dot get type. You see, this function is inherent from the generic object class. So then we get a type. But what we need, okay, never mind, maybe we just get a type there. So we will report type of fuzzy set full name. We will print out the full name here. So we needed to get the type of name first, right? So back here, so we get the string. We have string again, string read line, and pass it again. So we will assign out a string equals string dot substring. So right now, string is what is the fuzzy set type. It should be a full fuzzy set type name. Okay, so we have the name specified, and then okay, we will so once we read in the, so at first we report the type name, right? So we will get the type name first, and then we will use this name to particular type of fuzzy set. So how can you do that? We need to get the type first. So we prepare a type fstype. So how can you get a type? Equal we will invoke a static function type get type, right? So if you have a type name, you can get type. So I use that string there, get type. So once I get the type, fs type, then I can use a class to help us create a particular fuzzy set. So I might call it, this class is called activate, activate. Activate is a Dynamic Framework class. They provide a static function called create instance. So what kind of information is needed for this function? It's simple, just give it a type. If you so So this function basically will invoke the constructor, the default constructor of this data type in order to instantiate an object of this type. But if you look into our generic fuzzy set, remember that in our generic fuzzy set, well, let me see. In our generic fuzzy set, the constructor asks for a parameter, right? So the parameter is a universe. So in order to invoke this constructor, we need to invoke another create instance function. So basically what we want to invoke is that even though right now I have a type, it's not enough. So basically we will invoke this constructor. We supply the type and also we supply the argument. So in here we will put fs type and then supply the parameter. So the creator, knowing that you are about to create this data type, but the constructor invoked will be the one with a parameter whose data type is a universe. So that is the way we treat that. So create instance, and then we will get a generic fuzzy set. I'm going to call it fs. Again, we have a red career camera, right? So remember that activator is a class defined in Dynamic Framework, and it provides a public function for us to create an instance of a particular type. So this function simply returns an object, but intrinsically that should be a particular fuzzy set, right? But again, we kind of cast this fuzzy set as a generic fuzzy set. So we cast the returned object into a generic fuzzy set. So make that happen. So let's check the code again. So in here, we try to get the fuzzy set, right? So before we write anything, any data for this fuzzy set, we print out the type first. And then so when we read in the type name, we kind of create a type object. Use this type object to instantiate a particular fuzzy set. Okay, so up to this point, we needed to do some debugging first to make sure everything is working well here. All right. So let me save everything and then try to compile it, and then we will step into debugging mode to check whether current current save model and the read model working well or not. All right. It seems all right. It seems okay. So maybe. It's about the time we tested it, so we needed to complete some quick event subscription. So right now we have a read model file, right? We have set model function ready, no any reference to it, right? So it's okay. It's okay. So we return to our design screen. So we start add some we subscribe, save and open function here. So I think the last time we have defined this event handling function, right? So we have a save tool, right? So we have save tool stream menu item, click here. And how about read, open, Now yes, so we subscribe this function too. All right, so we have save tool. So it's about the time we dynamically create a dialog. That should be a save file dialog. And I call it DLG, instantiate it. All right. And then popular showing up DLG show dialog. Interact with the user. If the result of the show dialog is not equal dialog result.ok, we will do nothing. We simply return it. So similarly, when you open, when the user try to open a file, we need to prepare open file dialog, DLG, new open file dialog. If DLG dot show dialog result not equal, then result OK. Then you simply return it. Nothing will be done right here. So in this moment, we have a user has specified the file, right? So we will ask the model. We will invoke that function, save model, and then pass the file path specified by the user, dlg.filename. That's it. So similarly, so when user try to read in the model, right? So we need to invoke open, read model, dlg filename. Okay, seems okay. So we kind of start tracing from this part. Try to save our model. We have two universe. Universe 1, user has specified a fuzzy set, Gaussian fuzzy set, error fuzzy set. So the first one is Gaussian fuzzy set. The second one is triangular fuzzy set. Alright, so up to this moment, the user try to save its model. So in file, we kind of save it, right? And we save into probably on the desktop. Back to our, I might add a subfolder. Sample files. Okay, call it test 001. Alright, so up to this moment, we answer yes. So the file name is right here, test 001. So we enter this function, came to this place. So we check Mandarin, right? So street right model Mandarin. Then pick up the number of universe specified by the user up to now. So number is 2. That is for the input universe, right? So let's know the 0 is for input universe. So number of input universe 2. And then we loop through each universe. So pick up the universe first. It has been hidden within this tree node, right? Okay, so we got a universe 1. Then we ask a universe 1 to save model. So I hit F11 key. We came to this save model file, or what? Or the universe class. So universe class is simply right name. The name right now is universe 1. The minimum value -8. Fine. So you need to complete the data saving for the universe by yourself. Okay. So far we simply save these two data. I mean, for the universe. So once universe has saved, right? So we need to check the number of fuzzy sets defined in this universe. So we came to the count. We have 2 fuzzy sets defined on this universe, right? So we write number of fuzzy sets 2. Then we loop each fuzzy set right here. Start from 0. So we pick up the fuzzy set first. We know it has been hidden in this subtree node top take, right? Alright, so we find the fuzzy set. The first one is Gaussian one, right? So we get type first. So let me execute it. So right now type is what? See, type is in Gaussian fuzzy set. So full name should be described in this way. And then we are about to print out the full name here. That's it. we have not asked the fuzzy set to write its parameter in this moment, but it's okay. It's okay. Up to this point, it's okay. So J, the second fuzzy set, right? So the second fuzzy set, once we get it, Fs, in fact, is a triangular fuzzy set, right? But we still regarded that as a generic fuzzy set, so it's okay. Then we get the type. So up to this point, the type is what? It's a triangular. It's the triangular fuzzy set. So we print out the full name of that type. All right, that's it. So that complete the first universe, right? So right now we enter the second universe. The name is universe 3. Save it. Well, I kind of skipped the detail, right? So never mind. Let me move to this place, up to this point. So after that, we close the upper file. Okay, so it's done, right? So let us maybe take a look at the saved text file. So where is the file? The file has been stored in the simple file, right here. So test one is the one we just saved. So open it. So that is the content of our model file. Mandarin number input universe 2, universe 1. So this part is for universe 1, right? So this part is for the second universe, but they are input universe. We have not prepared code for the upper universe yet, but it's okay. So up to this point, type name has been specified, right? So far so good. Well, so maybe let us read it back. Let's read it back. Okay, so came to this place. So then user click on the click on the file, open. So users specify this as the model file, input file model. Open it. So we came to this place again, DRG. All right, the same file name. So we step into this function called F11 right here. So we instantiate a string reader object to help us read in the text file, read in the text content, right? So this is the first time we read it via this string reader. So what we get is that this is the string model colon Mandarin, right? So we apply this substring function. At first we get the location or colon and start from that position, shift by 1 character, then we get a substring. So right now substring is right here, model type. So model type is Mandarin, right? Mandarin, right? Then we switch the case, right? So since it's a Mandarin, so right now the user interface needed to be set property. The property needed to be set to be consistent with the selection of Mandarin. All right, so you need to do the rest of UI initialization by yourself. Okay, I'm not going to do that. Okay, it's done, right? So continually we read in the second line, right? So read in the second line should be what? Number of input universe colon 2. So similarly, we get a substring and then pass that into the int. Oh, okay. So number we got is 2. So we know there are 2 input universe specified in this model. All right, so node 0. Well, okay. So we kind of clean up all the tree node, right? First. So we step into the first universe. All right. So here we instantiate a universe first by sending the chart model in it. So we create that universe first. And then we let this universe object, this newly created universe, read related data from the file. So let me step into this function. F11 key came here. So we came to this newly created universe, right? So we try to read in its data, related data. So again here, so we continue reading in from the file string. So we read in this line. So how about this line? So you can see name colon universe 1. All right, so get a substring. All right, Okay, node is not instantiated, right? So node is not instantiated, so we need to instantiate. So up to this point, we know there's a bug, because dynamically we create this node and assign that to this universe. So this part is none. So our code does not work well. So let's go back to reline. So that means once we set the text, we need to have a tree node ready for it. So probably it's better that means let us go back to the upper place. So when we read the model, so we create universe, right? So then we have cleaned up the tree node, right? So it's about the time we instantiate a node. So once we create an universe object, it's about the time we create tree node. Tree node, new tree node, right? And the text should be what? So far it's not good at all, man. We need to pay attention to the sequence, because up to now the name has not been formally read in yet. So maybe we just bring it there. So once we have a tree node, right? So we will add that. Add a tree node, right? The node add tr. And also we need to set what? UNI set tree node tr. So we kind of instantiate a tree node first and then attach that to the tree view. So after the universe read its name back, after it's read back, then we set text of the tree node. So in this point, text equal uni.name. So from time to time, we need to pay attention to the instantiation sequence. At first, we needed to let the tree node exist, because once we set the name, the universe will ask the tree node to set up its name. So probably we don't need this, right? We don't need this, because during the name property modification, the tree node, the text will be set there. So never mind, just let me set a breakpoint here. Last time we crashed right here, right? So in this time, nothing has been instantiated yet, right? So probably user click on scanner and then he tried to root in the model. So open the file model, and definitely that should be the maintenance system, right? So up to this point, we entered it. So similar procedure, okay. So initially, RDB maintenance is not checked, right? Check it as forward. So it's about the time we check it. So let me continue up to this time. So universe 1 has been created. Tree node has been created too. And this tree node has been assigned to universe. So it's about the time we ask universe read its own data from the file. So we hit F11 key to this point. Alright, so we have written the first line, name, right? So we get a name. That should be universe 1. The name should be the universe 1. Okay, fine, great. Everything is down there. So then we read in the next line. Next line is low bound -a. Low bound -a, right? Okay, so this is string. So we pass that string, get the substring, and then we assign meaning as -a. Okay, it's done. So remodel file for current universe implementation is done. So it is done, right? So then we step into the sublabel. So that should be the list. Should be a list of fuzzy set. So back to the main form, right? We keep reading the next line here. So string right now is what? Number or fs, number of fuzzy set 2. So pass it, number of fuzzy set 2. So look through each fuzzy set. So then we read in the first line. The first line should be the type name, right? Okay, so we get the first line. Fuzzy set type name colon. That should be your namespace dot particular class name. Gaussian fuzzy set. Fine. So the string should be should be a type name. So use the string to create a type object. Right? Okay, so we have a type object ready for us to use it. So this is the type. In particular, it's a Gaussian fuzzy set type. Full name is right there. So we ask this guy help us activate, create instance. Let me hit F11 key to trace into that function. Right? So we came to the constructor. We came to the constructor of a Gaussian fuzzy set. You see, universe one. Universe, the parameter has been passed in, so that should be universe 1. So okay, everything is good. If because I hit the 11 key, so right now we are in the generic fuzzy set. So initialize everything, complete the execution of the constructor, and then back to the constructor of the Gaussian fuzzy set. So up to this point, two parameters have been ready there. Okay, name has been set. That's it. So far. Everything is okay, right? All right, this is the first fuzzy set. How about the second fuzzy set? So second fuzzy set, we read in from our file. Okay, it's a triangular fuzzy set right there. So we get the name, use that name, instantiate a type, use that type to dynamically create a triangular fuzzy set. But we regarded that as a generic fuzzy set. So fs is ready here. Alright, so everything is okay. See, alright, so it's all, we are almost done, right? Well, excuse me, this is the universe 2. So let me move to this place. Disable the breakpoint, move, execute up to this line, continue. Alright, so everything has been resumed, right? So we were at the universe, input universe. I'm sorry. Yeah, right. Universe. But we did not add a tree node to fuzzy set, right? So again, we need to remedy this, right? Okay, so where should we do that? That should be responsibility of main form, right? So when we read a model in, right, we clean up the universe, input universe. So similarly, up to this point, you are about to deal with the fuzzy set. So fuzzy set here has been instantiated, right? Read in a line up to this point. So we create a tree node. So tree node, new tree node. How about the name, the text? So I kind of use fs name to name this node, and then we need to add to where. We need to add this tree node to info fuzzy set node I, the universe, right? And that is the correction of the children of the universe. So node add a node. Also, we need to assign the tree node to this fuzzy set, right? So fs set tree node, a node. Okay, so you need to recover everything back to your tree node. Well, when you read in a model from file in this kind of pattern. Alright, so supposedly user click on this guy, and probably user has defined its own universe is fine. So when user click on open file here, and then so we let this function executed, disable this breakpoint, run through it. As you can see, it resumes everything. Gaussian one, triangular one. We do not define anything in universe 3, so it's okay. Alright, so you should follow similar structure to complete each the set model, read model function of the particular class. So we still have one thing needed to do, is that because we in file save, right? So right now we print out the type. So it's about the time we specify that fs you should save model. And then we pass in string writer to this fuzzy set, right? In the beginning, we asked the universe set model, right? So when we look through the fuzzy set, similarly, we will ask the generic fuzzy set model. All right, set model. And once we instantiate an object of that fuzzy set, right? Fuzzy set has been created, so we will ask fs read model, and then we pass in the string reader for the fuzzy set. Right. So up to now, there is no such function exists in generic fuzzy set, right? So we let the Visual Studio add that function skeleton for us, remodel. It's not working yet, right? Generate method. Okay, and also, where is it? This is read, right? Save read. Oh, okay. Also, that has been right here. So let me move to this definition. Go to the. So basically, it will be added to generic fuzzy set. But we know, for the derived class, they might have their own implementation. So where is the read model? Right here. Where is save model? Right here. So I paste them here. So these two functions is generated from the Visual Studio, right? So declare that as public. So it's about the time we implemented this function. But since children might have its own implementation on this file, so we will declare that as virtual. So remember that it's a family, right? For generic class, it's family. So we will focus on the data defined in each label or this class hierarchy to let each class dealing with its own data. So right now, for a generic fuzzy set, what kind of data we have? Don't bother about this random number generator because it will be created dynamically, right? So name has been specified within the generic fuzzy set. So it's a responsibility of generic fuzzy set to save the name, save the parameter, and what? And this property, because this property might be changed by the user, right? And tree node has been taken care by the by the main phone, so we are not going to worry about that. So the responsibility for genetic file set in SAFE model, we need to save this information. Okay. So we move to our SAFE model here. Alright, so since we have a string writer, right? String writer, write line again. That should be a formatted string for that. So first thing is that we need to report the name. Name. And then we need to special number of parameter has been instantiated. Okay. So SW, write line. Number of parameters. Parameters, since it's a C# array, so there's a property for us. We can access the names. So how about the value? So right now we look through each value, right? So for well, actually you can use for each. That's the double, right? P in parameters. SW, right line. Well, PAR, VALU, parameter value. So P. So if this generic file set has two parameters, different, there should be two lines printed out up to this moment, right? So name parameters you show membership function curve. So we need to specify that. All right, SW, write line. Show membership function, column. Show membership function, where it's totally up to you. Okay, so you can use different kind of expression or description about this data. Show function curve. All right, supposedly I end up right here, and then when the generic file set read in from file, you need to do it in read the file in the same sequences as that in saving file. So we will do what? We have string str, right? Str, you go what? SR, string reader, read line, right? First, and then we ask the trim. After that, str dot substring index O. That should be a member function, str.indexO. Find the colon character plus 1, we get the substring, and then we know it should be number of parameters should be an int, right? Excuse me, the first one should be the name, so sorry about that. So that's our name assigned with this string, this substring. So this is our name, and after that we will have int number of parameters. So we read in the text line first, then get a substring, and then we ask the int data type parser that string for us. So we will get number of parameters. So once we have number of parameters, it's about the time we instantiate the array, new double numbers of parameters. Right? So once we have this array ready, then we can read in each parameter value, following the same procedure, order sequence, right? So we kind of for int start from 0, I smaller than number of parameters I plus here. Read a line, but here we need to prepare properly. Within this block I have a block variable v value, so we know it should be double, right? So double, right? So we kind of read in a line and then pass that as a parameter value. So in here probably we don't need it to specify this block variable. We can directly assign the value to index parameter. Yeah. So up to this point, the parameter has been taken care of, right? Parameter name, and the last one should be a flag, whether this 46 should show it's a serious curve or not. So again, we read the line in, but instead we will ask bool pass that substring and set it to where? Set it to this variable, show members function curve. Okay, let me change a little, change the name, rename it. Show member curve. Alright, so that end up for this function. Almost all the data has been retrieved from this read model. Okay. But how about triangular fuzzy set? How about the Gaussian fuzzy set? If they have their own particular data, they need to overwrite and call the parents read and parents save mode. So let us quickly check about the Gaussian fuzzy set. Gaussian fuzzy set, right? Gaussian fuzzy. So if you look into the contents of a Gaussian fuzzy set, is there any extra data defined within this this class or property? No, right? So this parameter 0 has been taken care in the upper class, so we don't need to do that. Or we do have, right? We have COA quiz value setting. Oh no, it's not. Excuse me, it's not not a setting. So it's okay. There is no any extra data defined in Gaussian fuzzy set, so we don't need to override it. Right? How about the Gaussian? Excuse me. How about the triangular fuzzy set? So the same situation happened, for the triangular set. There is no any extra data defined in triangular fuzzy set. We don't need to do extra work. Alright, so fine. For this primary fuzzy set, we don't need to add any we don't need to overwrite the save model and the read model file at all. So let us check about a unary operated fuzzy set. Unary operated fuzzy set, right? Okay, so take a look at the actual data. Unary operated fuzzy set list. What is this? I don't know what is this. but definitely we will have a what? We will have a unary operate, and we also need to record a genetic for this the operand, right? So operand should be what? Should be the target for this, which has been defined before. But right now we need to save this date, save this information, right? But probably this operand has been the data has been saved into the file, because right now what we have is just the reference only, the reference to a generic file set. But this reference might be required, I mean, for unary for this operator, because each unary operator file has its own unary operator. So we need to report the data. We need to report the data of this unary operator. But we also need to report a reference, the reference to this genetic file set, in order to save in the file. Okay, so we need to overwrite and also call parent function for save and open model. Okay, and the constructor, unary operator constructor, it's okay, because not just the universe, right? We also needed to know the operator in the fuzzy set. So it would be a little bit difficult for us to resume it and during the model read model file. So it had better that we prepare a default constructor. The default constructor may just require the universe. So in order to invoke that, so in here I kind of, because to support the model read and the model save, I needed to add another constructor. This constructor should be a simple constructor in order to instantiate an object of this operator for this first, and then we will ask this for this to read in the rest of the data, right? So in here I kind of create default simply for model read function. So I will have a constructor similar to the primary for this array. They do not, what they need probably just a universe U. So in that case, I can pass that universe to the base class. So nothing is really done within this constructor. Simply pass the universe to the parent class. Okay, so our unary operator for this set, we kind of add a default constructor for model read. But in this moment, we need to override because we have actual data about the what is this list? Let me check a little bit. References. Content name. Add the name. Why we need this unary operator for this set? Okay, you don't need this list anymore. Probably this student want to do some name login, so it's not important. I mean, from my viewpoint, it's not necessary at all. What we need to just save this operator, and then we need to save the type of a particular unary operator, and then store their parameter data first, and then we will store the hash code of this file set, the target file set. And also, do we have any other property that can be altered by the user? No. Okay. So it's about the time we override the function. So type the keyword override. IntelliSense will pop up. Those virtual function has not been overwritten by this class. So we will override what? Save model, read model, save model, and also public override open model. Excuse me, read model. Okay, so the first statement should be a call to the parent save model file, because we have override it, right? So we need to call the base save model first, and then we save our particular data. All right. So what kind of data you should provide? For each unary operator file, definitely you should have a unary operator, right? So unary operator will be printing out. So in order to get the let me rename this function read model L. Apply it. So save our particular data, right? So the first thing is that we need to ask the string write line string. So we'll print what? The name probably maybe change fine the name, but the type. So similar to what? Similar to similar to generic file set, right? Similar to the generic file set. Let me move this function to that. So when we try to save up the type, so save the model number parameters. No, not here. It should be in the main form. Yes, right here. So we need to do some. So the first thing we need to write. So here we need to prepare a type first. Op type equal what? Equal the operand. We need to tell the model reader that the particular data type of this operator. So operator, the operator, get type. Then you print out, we save the type of name, the full name. Okay, so I will say operator, excuse me, operator, operator type name. It's a type of name, it's not a name. So operator type of name. Put it here, so that should be the op type full name. So I need to save the full name. Okay, you save the full name first, and after that we will ask this operator, the operator save model. We pass string writer to it. Okay, so this part is for the operator. Then So since the fuzzy set has been saved, right? So we are not going to save the same data again. It is meaningless. So in this time, we will simply write line string fuzzy set hash code. So we will save only the hash code of this operand. But we need to save detailed information about this operator. Operator has uniquely defined in this unit operator fuzzy set. So we need to do that. So hash code, once we get hash code, probably that will be all for this particular for the particular data of our unit operator fuzzy set. So you need to do the similar work for binary operator fuzzy set. I'm not going to do that for you. So once you realize this kind of hierarchical procedure, you should do it by yourself. Alright, so since we kind of save our model in these sequences, when we read in the model, we needed to again prepare a type, right? So we will prepare a type. So this is the first line, right? Get type, print out type. So we will have a string str, ready for us to use. So when we ask a string to read line, it should mean sr read line in trim. So we store it into string str, right? Which will be similar to this part, right? So when we read in right here, so read the substring. So and then str equal str substring index of str index of find the location of the column plus one, get a substring, and this part substring will be what? Will be a full name. Well, probably I will set up a local variable string type name here, and then I will prepare a type object. I still call it op type. So how can we get a type? There is a static function type dot create type. By entering the type name, you will get an object or type. And then after that, we kind of ask the help from the activator, SDIV activator, create instance. And I think for the generic operator, we do not need to provide any argument, right? So create instance, then we put the type there. So once we create instance, the type is object, right? So you can cast that as unary fuzzy set operator. So here, unary fuzzy set operator OP is dynamically created with the help of activate class. We don't need to supply any argument for it. So once you have OP ready, then it's about the time we hand over this read model responsibility to OP dot read model SR, is that into operator. So as you can see, the operator same model OP. Well, if you like, I can rename it the. So it does not matter at all because both of them are actually. Oh, excuse me, not the case, because we do have the operator, which is a member, right? So the operator right here. So I'm sorry, the operator will be instantiate by this line, activate the create instance assigned to the operator. So once the operator has been instantiated, then we can ask this operator to read their own data, right? So we ask this operator to save data, ask this guy read data. All right, so it's about the time we read in the code first. Okay. All right, so we will have code, all right? Okay, so we will have code needed to do that. So within this unary operator, because when we read the model from file, we keep a hash code of this operand. So we need to prepare a data when we read this what they say from file. We should temporarily store that hash code here. So later, the operand will be assigned by a function. Later we will create that function. Okay, so for this moment, we create int. I will call it oper and operand hash code. Okay, because we kind of print out. You see in here, we save. Oh, okay. And I like to make a correction right here. Last time we finished this, I did not. I just print out the. I just saved the operand. It's not right. So actually, we will invoke this operand. Operand is a generic fuzzy set. Ask this function get hash code. So again, when you execute an object in C# or in .NET Framework, the Visual Studio, actually the platform actually assigned the object with a particular hash code. The data type of hash code is int, so you can treat that as an ID, an integer ID, uniquely ID. So later on, if we want to bridge or want to connect the references between objects, you can use the hash code to bring them together, to connect them together. So for this moment, you just follow the instruction that I give it to you. So because our fuzzy set has been instantiated in some other place, later on we needed to get their reference. The only connection should be this hash code. So we needed to save this hash code. Okay, so the fuzzy set get hash code, we save it here, right? In unary operator fuzzy set, so we have the target fuzzy set hash code store right here, and then once we create our model, save model, remodel. Right, so this is the operator, and then we were reading str read line, sr read line, similar work right here. So right now we know it's a hash code, so we ask the integer parser this string for us and assign that into the operand hash code. I cannot remember the operand hash code. Okay, so for a unary operator file set, additional information needed to be saved. For example, the data of the operator. So later on we will instantiate a particular operator for our unary operator file set. And since the file set has been saved in some other in the very beginning, so we are not going to save the same data here again. Instead, we simply save its hash code. So later on, we can compare the hash code and then reconstruct the reference link between a unary operator file set and its target file set. So that is the purpose. So later we will return to this place to make to add another function in order to reconnect the reference relationship between primary file set and this unary operator file set later. But for this moment, let me add save model and the read model function for the unary operator. Okay, so we ask the Visual Studio help us to generate this function save model operator read model, generate a method here. Alright, so let me go to this save model. So go to the definition. So now we are here, right? So again, we declare the accessibility is public for this function. Alright, so remember that actually we have a family of unary operator, right? Unary operator, right? So we had better declare this as virtual. In case user do add a very a derived operator, so they can override this function. So what kind of information should we save for a unary operator file set? Definitely we have a name, right? And also we have parameters. So this kind of code is similar to the generic file set. So in save model, we will ask string writer write line name, or probably I like to add OPER operator name, and I think it should be capitalized, right? Name. So similarly, we will read in string str sr read line string. Okay, so our name, well, I can use lower cases. Name equal string, substring, index of, that is a member function, or str. str is a string. Index of, find location of current character +1. So that will be the name, right? So we save the name, we obtain the name back, and it's about the time we declare a number of parameters. So sw write line number here params. So that should be the parameters, since it's an array, right? So this always has a property called length for you, right? All right. So similarly, I will have a number block variable. Then I read in the next line, get substring, parse it. So int parse string subline substring excluding substring, and assign to what? To number. So right now I know the number of parameters defined in this operator. So once I have a number, so about the type parameter, I can instantiate it double numbers. Right, so we report number of params, and then it's about the time for each. The data type of a parameter is double p in what? In parameters. Okay, but here we should say for int I start from 0, I similar number, I plus plus SW right line switching PAR value. So P, right? So if the parameter has 2 elements, then each element will be looked through and then print out in this line. Okay, so when we read it in, right, so we instantiate this array, so it's about the time parameter assign value to parameter I. So how can you do that? Well, we need to read in a line and then do the parsing work, right? So read a line, get a substring, and definitely we know it's double. So double that parser the obtained substring and assign it back to where? Back to our parameter I. So all the parameters saved and read has been taken care in the genetic unity for this operator. Okay, it seems fine, but we also specify our function virtual. So if you have a particular unity operator, you might need to override the inherit, save, and read model file. Okay. So up to this point, maybe we should do some debugging task first to make sure everything is working well. Okay, so let's save it. Gaussian for this set. It is for this set, right? And probably after that, set the Gaussian for this set, we have concentration. Okay, maybe value cut for this set specified. So we add a 0.5 Gaussian for this set, and probably user has changed the parameter into probably 0.8. And it's the time the user set the model. So user set the model into test 002. So actually 01 is not valid anymore, right? So but yes, test 2. So I am not going to step into that function, so let me just execute it. Okay, okay, great. So normally, normally it's our unity operator, okay, so about the, I think it's related to the unity operator for this set, because there is no any parameter specified in the unity operator for this set, right? So number of parameter, you try to access the length. But for parameter is never instantiated, right? Parameter is none. So this kind of error message generated. You did not set the object reference. So the error came to here. So actually, in a generic for this set, you try to save the model, right? So you save your name and then you try to write the number of parameter. But only when the parameter is not none, you need to do that. Right? Okay, so we need to change it, the code a little bit. So then we add another condition: if parameters none equal none, then we need to store the number or parameter and store the parameter value, right? So in this case, okay, so if it is none, but if it is none, we need to let the system know that. So else we will write. Still, we need to write this line. Else number of parameter is what? Is 0. So if it is 0, we are not going to instantiate. We are not going to instantiate any parameter for the parameters, right? So if it is not none, then we will report the number of parameter used. Otherwise, we report the number of parameter is 0. So up to this point, once we read in number of parameter, right? Number of parameter here, we are not going to new double array with 0 element. So if number of parameters greater than 0, we instantiate the parameters, right? Otherwise, we do not do anything. Okay, that make this good. So similar logic should be applied to where? Applied to the unity operator. So let's go back to our unity file set operator. We kind of report number of parameters, right? Number of parameters right here. Right. So, and then we look through each parameter, right? So in here, we need to make sure if parameters none equal none, then we print this out. Yeah, it should be a bracket. Else, we simply write a line, tell the user, tell the model that number is exactly 0. So when we read in the number of we read the number of parameters, right? If number greater than 0, we instantiate this parameter array and then read in each value from the file. Okay, so that makes it simple. So let's debug it again. Okay, we have L, so we need to solve it. So once you have compilation error, make sure you click on the first one. Alright, so we don't need to use this placeholder, right, to read the report as 0. Alright, so we quickly select Mandarin, add a universe. In this universe, we add a Gaussian function. So the Gaussian function, we add a value cut for this set. Create. So 0.5 cut. Right. Maybe we can change the name a little bit, right? So I might call it temperature. So universal temperature. Gaussian, probably I'll call it hot. So 0.5 cut hot. Fine. So when user click on the file save, it specifies a name tst0003. Save it. Okay, maybe let me trace into this function again. So right behind, we print out model Mandarin, we print out number universe, rip through universe. Right now we have two fuzzy set, right? The first one is the primary fuzzy set. So the first one, again, hot. Name is hot. And we save the type file name. And the second one, save it. Alright, save it. So done. Okay, let's continue it. So up to this moment, right? Let me quickly check the content of the file. Sample file. catch the 003. So this is the content up to this one. Maintaining number of units 1, name temperature, row bound -a, number of fuzzy set 2, fuzzy set type, right? It's namespace, Gaussian type. Name hot, number of parameter 2, right? Since it's a Gaussian, so center and center deviation. Show member function true. Fuzzy set type, unary operated fuzzy set. Name 05-cut hot. Number of parameter zeros. Show member function true. Okay, take a look at here. Operate type name is a cut fuzzy set operator. And then operator name 0.5 cut. Number of parameter 1. Parameter value 0.5. Fuzzy set hash code 109201. Okay, interesting. Alright. Okay, I think so we need to add another thing. Because later on, if we want to bring back the reference of this unary operator fuzzy set to the target fuzzy set, we need to store the written hash code in the fuzzy set. Okay, in the generic fuzzy set. Sorry about that. Let us quickly go back to our generic fuzzy set. Our generic fuzzy set. Here, generic fuzzy set. So when it's about to save the save the model, right? Save the model name. After the model name, I will add another property to print it out. So right, I call it hash code. So I simply ask this that get hash code. And then if we want to read it in, so this is a generic fuzzy set, right? So in this moment, we will have to support the read model. We need to add needed to add an extra data for hash code store. Alright, so when we read the model, we will, so this is the number, right? So we will read in the hash code, SRSRE in this call. So right now we know it's an integer. Hash code is an integer, so we ask integer parser this string for us, and then assign the integer into this hash code. So for a generic fuzzy set, if we want to save the model, you need to save its hash code to the file. And when we read in fuzzy set, we will read in hash code and then temporarily store the hash code in this variable. So later on, for a generic fuzzy set, we need to reconnect reference somehow. Okay, reconnect reference somehow. And since it is a generic fuzzy set, so generic fuzzy set always depend on another fuzzy set. So we will provide what public function called virtual void. We call it reconnect fuzzy set. Reconnect fuzzy set reference S fuzzy inference system, but that should be the I'll call it existing fuzzy set S. So it's a virtual function. We connect fuzzy set references. So let's go back to our unary operator file set, because we have a reference refer to existing file set, right? So we need to override it. So later on, when our main phone has read completed for a model file, the last step should be reconnect each other, reconnect the reference with each other. So by that time, this function will be called by the main phone. So that means a generic file set have this kind of functionality. If generic file set depend on another file set, so they have been read in, has been saved as a hash code. So we need to reconnect the reference via this hash code reading. Okay. All right. So this is the hash code, and usually we will make that as public. So declare that as public int hash code, and probably we will set and provide get like that, and we do not have an initial value. So we have hash code store existing file set. Okay, so who needed to override it? This one, unary file set operator need to override it. You see, so when we save the model for the excuse me, not this is operator. What I'm saying is operator file set. So when we save the model, we kind of save the target file set. We simply save the hash code, right? So when we read it in, the target file set has been reinitialized, recreated. So the reference will be different from the previous one when we save the model. So about the time, I mean, we need to override it. So we kind of override this one here, override. Reconnect file set reference model. So how can we reconnect the reference of the operand? So system will provide all the existing file set for us. So this is existing file. So basically what you need to do is that for each generic file set fs in existing file set s, we need to check if fs hash code store is exactly the same as the one we read in. So where did you read in? The operand hash code, right? Equal operand hash code. So bingo, right now we get the current reference, right? So only in this case we will assign the operand equal fs. Since we have find it, right? So we will break. So this part of code is that this function will be called when a model is successfully read. So only through this function we can reconnect the newly created operand. So we will maintain this reference relationship between this unary operator file set and its target, its primary file set. Okay. So later on, if I have time, I will explain this mechanism in detail somehow. So we still have purple camera. So adding an abstract method or override and inherit method will prevent the debugging. Oh, okay, I'm sorry, we are in debugging mode right in this moment. So, okay, it's done. Okay, so at this point we have read point, we have hash code edit. So let us again debug our current model. So user add a universe, add a Gaussian file set, select this Gaussian file set, add a cut, value cut, operator file set, and we like to change the name of this universe into property temperature, and then property the minima maybe into 1 minus 10. We also change the Gaussian's name, maybe change it into hot temperature. Alright, so okay, that's it. So if we use click on save button, so right now we kind of test 004, save it. So I'm not going to step into this function, so let it execute it to the end. So fine. After this point, we have a model created, right? So right here, and if we read it, so the difference is that we add a hash code, right? So it's a mundane system, one universe, temperature minus 10, number of fuzzy set 2. This should be the first fuzzy set, right? First fuzzy set, type as Gaussian fuzzy set, hot temperature. Okay, right now we have hash code area right here, right? Okay, this is the only information we can reconnect the operator fuzzy set with this primary fuzzy set. Okay, for this Gaussian fuzzy set, we have 2 parameters. Fine, shortcut. How about the second fuzzy set? Second fuzzy set is unity operator fuzzy set. This unity operator fuzzy set depends on Gaussian, right? So, okay, name. Again, this guy has its own hash code. Number parameter 0. Show me point yes. How about the operator? Operator information right here. Operator type of name, cut operator. Parameters, no any other parameter, right? So, well, operator name right here. Number parameter, yes, we do have parameter. So 1. Parameter value 0.1. So this part of information is related to the operator, right? But how about operand? Well, operand, we just save the hash code. We don't need to save this data, the whole data again, right? This hash code is indirectly linked with this hash code. So later on, when we read in this, read in and create a new Gaussian fuzzy set, when we read in the file, this information will be stored in newly created Gaussian fuzzy set. And then also, when we read in this unity operator fuzzy set, we also read in this hash code. But only after all the fuzzy set has been constructed, we will need to assign the operand for this unity operator fuzzy set in order to refer to the newly created Gaussian fuzzy set, because the address will be different from last time, right? So we are not going to save the address at all. We will save its hash code in our file. So later on, we can retrieve the connection between this guy and this fuzzy set. So that is the idea we are doing. All right. So let's come back here. So if user maybe open the file, open file again. So this time open test 005 4. All right. So let me step into it. Oops. Model save its data cell, right? But since we are in the main phone, right? So we need to assemble the rules and then update the for example, update the mundane rules. So after that, we will ask the mundane system to save its file. So within the mundane system, the mundane system will save information or the rule. So save rule first. Create rules array. To update rules of fuzzy system. So our ultimate goal is that we need to ask maintenance system update rule set. So we will prepare a rule set, right? We will pick up the current rules defined by the user from data grid view. So we create that. So basically, what we need to have should be the maintenance if then ULES, right? Okay, so it's your job. You need to loop through data actually DGV loop through DGV rules to create UL rules. Okay, so it's your job. I'm not going to do that for you. So basically, what you need to do is well, actually you have done that, right? When you click on this button, you kind of set rule, but again, that is the list. But right now you need to create an array, rules array. So you simply look through all the data grid view rule, or the data grid view DGV rules, right? So you create instantiate rules and then put into this array, and then you ask maintenance system updates its rule set. So once the rule set is updated by the once the rule set is updated by the maintenance system, it is about the time we ask maintenance system to save its file, right? So we are here. Okay, you need to do that. Okay, update rule set. Kind of use these rules to then the maintenance system update says, and then, whoops. All right, what kind of maintenance if then rules? Okay, because this problem is the local variable. So you need to populate the rules by yourself. So once it's done, we will ask maintenance system save model. So up to this point, save model is, well, it has not been created, right? So similarly, right? So so we ask maintenance save model. So up to this point, when we finish the reading, so this part's reading all the universe, and then we ask maintenance system to read its data, right? So here we maintenance system save model and maintenance system read model. Should be SR. Okay, so we have not created that yet, right? But and then what kind of information we need to save? Because in our main form, user might specify what is the condition? Remember that we do have operator. If then rule, okay, right here. We have condition data grid view, right? So probably user has set up some condition. Well, up to this point, I don't think you need to save the condition. Yeah. Well, it's depend on you. If you would like to save the condition created by the user, you will need to add here. Information for the user. Yeah, if user special condition, so well, it's up to you. So you can add it, and once you add it, then you will need to read it back, right? So save condition information for the user. Then you read in conditions and populate DGV condition. So ask Mandana system to read in its data, right? And SO also populate DGV rules. So you need to restore all the information about the rule in your data grid because you are the main phone, right? So you need to once you read the model, you need to populate the data grid view to put so you basically you read through the Mandana's rules, and then you when you read it in when you read it in, all right. So so the best way is that because we need to populate our data grid view. So you see, you kind of aggregate all the rules from data grid view, right? And then update the Mandana system. So, and then the Mandana system save the model, read the model. I think probably the easiest once you complete the rules, you simply ask each rule. Well, it's okay. I mean, we might not ask the Mandana save model because we needed to interact with that. Well, during the read model, we needed to read the rule in from the main phone. Otherwise, you needed to provide. Well, just let us practice object-oriented technology. We simply let Mandana system save the model. Then Mandana system read the model, and then after that. Populate the data grid view of our rules. Okay, so it was very easy. I mean, since Mandana system has a rule set, right? We simply define a property. So let us go to identify this system. Oh, okay. What's wrong here? Interesting. I cannot access. Set model. Okay, so we are about to create this file, Mandana system. So you need to make sure what kind of model you are doing. So you see we have switch statement here. So right now what I have implemented is Mandana system. So you need to add a switch statement here to deal with different kind of inference system. So here is example for Mandana system, right? So you need to do it differently for Scamodo model and scalar model. So it's about the time we create this function for the Mandana system. So we ask help and generate this method. Also generate this method, and then let us move to this function Mandana system save. Go to definition. So right here. So again, similarly, we declare that as public. So currently, our Mandana system does not have a name, right? So if you like, you can add the name, the title. Probably user want to name its fuzzy inference system with a particular title, so you will allow to that. But so far, our Mandana system just have the attribute, the property, user cut operator, right? So user might change it, and so we need to save it. And also user might set a different kind of differentiation mode, and then we need to save this data. Not just this data, we need to look through all the Mandana if-then rule to let each rule save its own data. Okay, so that is the idea. That is the idea what we are going to do. But before that, because once we read the model back, we needed to access the Mandana fuzzy if-then rule in order to populate our data review. So in that case, all rules we should declare a public. We should declare a public property. Public as a property. So this is a Mandana fuzzy rule array. I might call it all rules. So it's read only. Yeah, we're not going to set it because we have this function to set the all rule, right? So probably if you allow it to be saved, but again, we like to have a function here. So in order to do add some guardian logic here. So all rules we simply provide get, and excuse me, it's not there as a property. So provide get, simply return all rules back. Also later on, when you read a model in, you can access the rules read by the Mandana fuzzy system back to populate your data review for rule. Okay. So what we needed to save probably should be, well, since we don't have a name, so it's okay. It's W right line. So in similar format, right? So we need to save this data as a ball, right? But the ball is simple, so we will say that, well, use cut. So data value should be use cut operator. So once you write a line out data, you will read in, right? SR read line, prepare a local variable string, str get a line, and trim all the leading and appending blank character. So after that, we ask string, substring, index O, str index O, find colon +1 get substring. And we know that the data should be bool type, so we ask bool parcel this string and return the data over bool. So we use that to assign our use cat operator. The interesting data is here. What about this differentiation type? Differentiation type is unique, right? We define that. So it's about the time we simply establish right line user cut. So that should be differentiation. So simply return this value. But if you save this information, it turned out to be a string. Strings is a little bit difficult for us to regain the integer value of this differentiation type. So we have better, simply because we know the value is an integer, so we have better just save the integer. So kind of cast as an integer. No way, right? But differentiation model, the data type, so we can cast it. We use cast. So we simply save the int value. And then later on, when we read it back, it should be integer. So we ask integer to convert that. But after it is converted into int, we cast that again as the differentiation type. It's a little bit tricky, okay, because you cannot just save the differentiation type. By default, it will be a string. For example, COA, BOA, like that, and it's kind of troublesome for us in order to get back the value of differentiation value. So we simply cast that as integer, and then when we read it back as an integer, we cast that into this differentiation type. So we will assign the red value to assign this data. Alright, so that is for saving the differentiation type. Alright, after that, we need to write line the number of rules. So how can you get a rule? That should be all rules. That length, since it's a fixed array, it's not linear. So similarly, we will get int number, right? How can you get number? Read line, get substring, convert that into int number. In particular, this should be the number of rule. Right. So after that, we need to look through each rule, right? So I smaller than number of rule. So similarly, we have this kind of save procedure. That should be all rules lengths. Right, so we are asked again similarly for a Mandani system, since I have a list of rules, right? And the Mandani if-then rule is actually a class. So I will transfer the save job to the rule, all rules, the ISO rules, save model. And then I will ask all rules read model. But before it save model, okay, fine, save model, read model. Okay, so we need okay, within the rule we need to Mandani system is okay. So we know it's Mandani type. For rule, because we have different kind of class, right? So we needed to well, properly, if you know what kind of okay, so we did the gray rule. Okay, so that should be the task for Mandani fuzzy system. Save the properties of this system and then ask each rule to save the model. Each rule read in the model. Okay. All right. Okay. So then we step into this function. That is on the Mandani if-then rule. So as I say, because the reference each time you open you read in a model universe, and the fuzzy set will be dynamic created, right? So the reference information will be different from the last time when this model is open. So the only way we can begin the reference relationship is via this so-called hash code. So a rule for a Mandani if-then rule, this is the information we need to save, right? But we are not going to save the fuzzy set again. We will save the hash code of that fuzzy set. So within this save model, what we need to report should be what? Should be SW write line number rules. So we always report the number of items in an array or a list. Antecedent dot. In this way, it's a dynamic array, so it's count. So after that, actually, if you like, you can use for each entity should be a generic fuzzy set, fs in antecedent. Right. So and then we ask SW write line okay, and antecedent fs code. So we will save hash code for that fuzzy set. Later on, when everything has been written and the object has been universe and the fuzzy set has been created, we will regain that kind of information to resume the reference relationship between rules and the fuzzy set. Okay. So basically, what we get is that we kind of write the code out. So during the read, you need to read in number. So SR string reader read line, put into the string So we can we just copy and then for the system remodel? Okay. Back to if then rule. So str and right now it's int parser number. So once you have a number ready, right? So it's about the time we repeat the time for int I 0 I small number I plus. So we need to reconstruct antecedent, right? So before that antecedent, we probably might have all the info, all the data there. So we quit it, and then we add it. But it's not antecedent mission. As I explained earlier, is you need to read in, because what you can read in is antecedent code. So actually that should be antecedent code and not antecedent. And this antecedent code clear. So we were what? We were assigned that we will get that data. So actually it's a string. So it's an int string read line int. So that should be the int antecedent code. And this is a list, right? Add this integer. This integer is a hash code, or the representing that fuzzy set. So that is the idea. All right. So we get the antecedent parts. And the last job we need to do is that we need to save the hash code, right line, antecedent fuzzy set, CON/CU conclusion fuzzy set code. So what is it? That should be our conclusion fuzzy set dot get hash code. So we save it, and then we need to read it back. So again, read it back, put it where? Put it temporarily here. Conclusion, fuzzy set hash code, not add, right? Equal, assign the hash code with this value. All right, that will be the value. That will be the value. That will be the read model function for Mandani if-then rule. Okay, so once everything has been ready in, we need to rebuild the reference relationship to the specified fuzzy set, right? So we should have a function, public function declare Yeah, I already defined that. You see right here, reconnect fuzzy set references. So provide all the fuzzy set, and then so we check that antecedent part. See, we create antecedent list, and then we add it at the fuzzy set. So once we know the exact fuzzy set, the new references, because the references actually is different from the last time, so we need to regain this reference relationship via this code, via this hash code. Okay, we have done that before. So that is reconnect fuzzy set references. Okay, so similarly, the if we bypass, well, the best way well, since it's a public function, so actually what you can do is that you once we read in everything, right? So we save it, and then once the Mandarin system read model, so that means Mandarin if-then rule has read in the hash code of fuzzy set. So after that we close up everything, and then first we reconnect fuzzy set reference for the for example unary operator fuzzy set and binary operator fuzzy set. So after that we reconnect information with others operator fuzzy set. Alright, so it's part. So we need to regain the rules. So what is the rules? So what you can get is that Mandarin fuzzy system, because we just set up a public property, right? All rules. So right now we can access the rule Mandarin system has. So we know it's Mandarin system, so we can for each Mandarin if-then rule, call it Mandarin if-then fuzzy rule. Anyway, rule in. We kind of look through each rule. So we will invoke rules that we connect fuzzy set references. So remember that we keep a list of all newly created fuzzy set, right? So all fuzzy set reconstructed. So we pass that into that function. So the rule will regain the connection, reference connection with the fuzzy set, the original fuzzy set, because the fuzzy set has been newly created. Reference will be different from last time when the model is saved. So that's it. I think that will be all for our save model. But remember that what I just done is for Mandarin system and the Mandarin if-then rule. In order to make your save model complete, remodel complete, you need to do the part for scanner fuzzy system, model fuzzy system. Okay, that will be all. If there's still some bug within this code, you need to try to solve it. But the whole idea is that we keep using the so-called object-oriented technology to let the class, each class, to let it deal with its own data, not just the data manipulation, also data saving, data read. That is their responsibility. But since in a model, we might the data field or class might be a reference to other objects. So if it is a reference, we will not save the same reference the target more or multiple times. So we needed to save is the code, the hash code of that reference target. So we keep the hash code. The purpose is try to regain the reference relationship after the model is read. So that is required All right. Some other guy might use name to reconnect the reference relationship, but again, the name is a string. Probably the user might have specified different objects with the same name. So in that case, name is not unique. So that will have a problem. So in order to regain the reference relationship, we kind of take advantage of the hash code prepared by the Visual Studio. So we store the hash code in order to regain the reference relationship after the model is read. So we need that. So as you can see in the rule, the magnificent rule, even though this data is the real contents for a magnificent rule, but since we provide model save and model read functionality, and since the antecedent they are all references, we needed to provide this kind of temporary data to keep the model's hash code. So later on, when the file set has been recreated with new references, then we can set the reference back to resume the reference relationship between the rules and the fuzzy set. Okay, that is kind of tedious and troublesome, right? But you should design this kind of safe and open mechanism. Yeah. And use object-oriented technology to do that. Okay, that's it. Good luck.